Hi, my name is Gregory Dale Smith. I'm the Otto N. Frenzel III Senior Conservation Scientist here at the Indianapolis Museum of Art, and we're going to take a tour of the Conservation Science Labs. So the labs began in about 2010 with a grant from the Lilly Endowment. We were able to carve out about a 3,000 square foot space here at the furthest extent of the museum, which ended up being ideal for a science laboratory. It's a nice, stable area without a lot of foot traffic, which is great for a lot of the types of techniques that we use on artwork. This is a purpose-built facility for art, which means that it's a little different from your typical industrial or pharmaceutical science laboratory. We do a lot of analysis on actual objects, and so we've taken that into account in designing the space, making large doors where we can bring in large artworks. In some instances, we remove the doorway entirely. These are techniques that we would use on artwork. They're light sensitive, so we have a blackout curtain, but we don't have to negotiate a doorway with a large art object to bring it in here. Some of the techniques that we use on artwork can be to identify the materials, maybe to help conservators plan their treatments so that they're effective but also safe and sympathetic. This is a laser Raman microscope system, so we're able to analyze anything we can bounce a laser off of, and by having our microscope slung out on this gantry, we're able to put even fairly large objects directly under the microscope. So we use this to identify corrosion products and pigments that might be used on artwork, various plastic objects. We also have some techniques which help us with our exhibition of artwork. So this is a light fastness tester that allows us to test the light fastness of dyes and pigments on artwork directly on the object, so without having to take anything or make a surrogate sample to test in one of our light aging chambers, which are actually downstairs. Also, in designing this space, we thought about the daily movement of art through the science lab and the needs of the scientists to always keep track of their colleagues, where exactly they are in the laboratory. They may have artwork in their hands or be moving artwork. So we don't have the tangle of wires and cabinetry and bookshelves and instrument racks that are typical in a lot of academic laboratories and industrial laboratories. We have a nice clean installation for our instrumentation, which has the added benefit of not blocking our views out these wonderful picture windows. Again, somewhat unusual for a science facility. So some of the techniques that we use are in the field of separation science, and that's because a lot of the samples we get are going to be very, very complex. Many of the artist materials are biomaterials, which means they have natural biocomplexity. The artist may also have mixed various things together, which adds another level of complexity. And then if they're aged objects, there's going to be pristine material as well as all the degradation products. So instruments like gas chromatography, mass spectroscopy, and liquid chromatography, mass spectroscopy, are used to separate out those complex mixtures and then to identify each of the components individually. Dr. Victor Chen is a volunteer in the laboratory. He's a retired biochemist, and he's been working on natural dye analysis, again an area where there is a lot of complexity, using this technique of LC mass spec, liquid chromatography mass spectroscopy. And so he's able to separate out the dyes in the chromatograph and then detect them and identify them using the mass spectrometer. We do a little bit of wet chemistry in the lab, mainly to prepare our samples so that we can analyze them on the various instruments. You'll see in the lab lots of microscopes. We just looked at a Raman microscope. We also have some microscopes that are used to view artwork at high magnification. For instance, if we needed to take a sample from an artwork or simply to document its surface. Other microscopes are tied to spectrometers, and so they allow us to collect spectra of very small samples taken from the art. This is an infrared spectrometer, which allows us to identify the organic materials and inorganic materials using molecular specificity. Other spectrometers in the lab detect elements instead of molecules. So, for instance, this microfocus X-ray fluorescence instrument can be applied non-destructively and in situ. You see the painting sitting on the easel, the X-ray tube is pointed at it. We'll irradiate that painting and then collect the characteristic X-rays which are emitted by the artist's pigments. And then we can infer from the elements present in those pigments what exact pigment it might be. When we do have to take samples, we have a suite of labs that allow us to collect samples from the artwork, to prepare them, mount them in resin, polish them, cut them, and then be able to analyze them at high magnification using this compound microscope. This is one of the only ways that we're able to really tell the layer structure of an artwork and understand the working methods of an artist. You'll notice that the Conservation Science Lab here at the IMA is a little bit different from other science facilities. Coming from a mixed background in both the arts and the sciences, I've never really liked the bleak white interior of most lab spaces. So in designing this lab, we chose to use decoration that was a contemporary take on the arts and crafts. So we have a lot of custom artworks in the lab that were donated by contemporary artists in that tradition, including our periodic table, which you see here, designed in the lab and then carved out by a local craftsman into a piece of mahogany. The artworks that you see in the lab are here not only as decoration, but to serve a didactic purpose as well. Many of the students and scientists who come to work in the lab are not familiar with the art-making traditions, and so these artworks provide surrogates that we can use to understand the art-making process and to develop techniques of analysis that are appropriate to art without having to draw directly on the museum's collection. The lab we're in right now is an electron microscopy lab. So we've traded light for a beam of electrons in order to get super high resolution images of small samples. Using secondary electrons, we're able to generate images like you see on the screen. This is of graphite, the sort of platy structure that's typical if you had a graphite pencil drawing. The electron microscope is able to magnify far beyond what an optical microscope can do. That image was collected at 2,640-fold magnification. Well, I hope you've enjoyed your tour of the Conservation Science Lab here at the Indianapolis Museum of Art. Thank you very much.